Alright, here's 6.6 inequalities in two triangles. We're going to talk about something called the hinge theorem, alright, and it comes from the little diagram here. It says, if you think about the hinges on a gate or window or a door, anywhere, right? Well, the gate has a set size, the door has a set distance, CA. The distance between the door and the doorway is set. The only thing that's not set is when you close the door versus as you start to open the door. And as you start to open the door, right, this angle gets bigger and bigger and bigger. And as the angle gets bigger, well, if I were to make a triangle, well, if I only open the door crack here, then that side BC is not going to be that long. If I open the door even further, then BC will get further and bigger. And if I open the door all the way, then if I try to draw a triangle from BC here, it'll get bigger and bigger and bigger. So let me explain that another way. Right, so this is called the hinge theorem. So if two sides of one triangle are congruent, then the other two sides of another triangle, and you include a first larger, then you include angle of the second, then the third side of the first larger is larger than the second. Okay, so let's make sense of this. So we got some angles here and some numbers here. So we just came out of the section where we said, okay, if we have a triangle, let's say this is 8 and 5 here, and we did another triangle, 8 and 5 as well. Well, your third side can be a couple different choices here for your third side, right? We said the third side could be less than the sum of 8 plus 5, or it could be greater than the difference of 8 and 5 is 13. So as long as I pick the side here between those two numbers, that's fine. So let's just say this is 4. And let's just say I create whatever angle I create here. Well, if I use the same two sides, but this time I use the side here that's 5, which is bigger than 4 there, then this angle here will be bigger than that angle there. So the larger or the longer I make this side here, right, using 8 and 5 for both of them, right? So back to this picture here. So this could be my 5 and this could be my 8 here, right? So if I choose to use a side bigger and smaller, the bigger the side I choose, the bigger the angle. Right? So since I chose, so if this was 8 and 5, if I chose to use 12, right, which fits within my parameters here, then angle C is going to be bigger than angle F because I only chose a side length of 9 for DE here. And the same happens here. Well, if I know these two sides are fixed, right, if this is my door, this is my 8 and 5, and I open it 88 degrees versus 35 degrees, well, the bigger the angle I choose, the bigger the third side has to be. Right? If this is only a 35-degree angle, then ST doesn't have to be as big as WX. Right? So the bigger the angle, the bigger the side, assuming that these two sides have the same fixed sides. Right? And that's the hinge theorem, and that kind of goes back to here, right? So the door length doesn't change, the door entrance doesn't change. It's just the angle that I open the door that changes. So how much do I open the door? The more I open the door, the bigger the triangle gets. Hence, the hinge theorem. All right, so let's take a look at this one. So given ST is congruent to PR, so we know this is congruent. And then it says, how does angle PST, so PST, how does this angle compare to angle SPR? Well, SPR is this angle. Well, PS is congruent to itself. So if I'm going to separate this, so I got PST here, PST, and this is congruent, this is going to be congruent, and I got a side of 24 inches here, and if I look at the other way, I got PS, and this time R, right, so there's my two congruent sides, and then I got this side here, which is 23. So PS congruent to PS. So one side has the same measurement. TS congruent to PR. So now I have two triangles with two legs that are exactly the same. The third leg is different. So this leg, PT, is 24. SR is 23. So now I can see that PT is bigger than SR. So if PT is bigger than SR, then this angle here, PST, is going to be larger than this angle here, which was SPR. Because again, that third side of 24 is bigger than that third side of 23. Making that side bigger makes that angle a little bigger too. Alright, given JK is congruent to LK, and then I want to know how does JM compare to LM. Alright, so again we have the reflexive property here again. And I know we have two congruent sides here. So I got JK and KM. So I'll separate these. So I got JK and KM. And then I got KM and KL. So JK is congruent to KL. Not so congruent according to my picture, but work with me on that one. KM is congruent to KM. And now lastly, all I know is, or I'm asking, that third side, which third side is bigger? Well, is JM bigger than ML, or is ML bigger than JM? And it's going to depend on that angle right there. So this one has a 64-degree angle. This one has a 61-degree angle. And since 64 is bigger than 61, then JM is going to be bigger than ML, or LM. Alright, that's all we got there. Definitely pause this one and see if you can figure this one out on your own. This one could be a little tricky, but let's see how we got here. So two Cooper bikers leave the same camp. So this is my starting point. Right, this is where we start. And they leave the same camp in opposite directions. Okay, so each group travels 2 miles, then changes direction. So the first group goes 2 miles, 2 miles to the left. This one goes 2 miles to the right. Right, so there's my same piece here. Then group A, right, we got group A, starts due east and then turns 45 degrees. Okay, so it's going north, south, east, west. So we got north, south, east, and west. Okay, so it's going, still going. Starts due east and then starts traveling north. Okay, so it's going. So now it's going northeast, but it turns at 45 degrees and goes this way, and now travels 1.2 miles. Right, and that's labeled for me. Group B starts due west and then turns 30 degrees. Right, so it's going 30 degrees and then it's going 30 degrees south. And this diagram was good. And then it says which group is further from the camp. So the diagram is already given to you. So we got some advantages here. So now we got this and this. So now we got our two sides here. So our first side that's congruent is this side, this part of the triangle is congruent to that part of the triangle. So here's the two sides that are congruent, 1 and 2. And then it says which one has a bigger side here. So I'm going to compare this side here to this side here. So who traveled further? And it's quick to say, well, I see the 30 degrees and I see the 45 degrees, so yeah, 45 is bigger, so Group A is further. Quick to say that, right? Because you see the numbers here. But be careful, because the 30 degrees is not referencing the angle inside the triangle, it's referencing the angle outside the triangle. So if this is 30 degrees, then this angle here is actually 150 degrees, because it's the interior angle, right? So this is the These are, the supplementary angle here, if you look at this, right? So this is the exterior angle, so interior is 150. This one is 45 degrees on the outside, so that means it's 135 degrees on the inside, right? Because these are a linear pair here. So 35 and 45 is 180, 30 and 50, 150 is 180, right? So you consider the linear pair. So I need to get back inside the triangle. So now when I consider this, okay, well, since they both traveled 2 miles and 1.2 miles the way back to the camp, well, since they created a bigger angle of 150 degrees, so 150 degrees is bigger than 135 degrees, Group B, to get from to get to its current location back to the camp, is going to have to travel further. So Group B has a bigger distance than Group A. Alright, so a little tricky on that one, using the exterior angles here versus the interior angle of the triangle, but fun problem there. So that's the last of Chapter 6. Hope you enjoyed it. See you in Chapter 7.